welcome. So in the last lecture, we talked a bit about the motivation behind looking at Riemann sums and kind of gave a warm-up to it. And then I'm going to give you, in some sense, the goal of Riemann sums so that this is clear in your mind as to what we're trying to do. And I'd say I'd like to give a certain amount of build-up to this and warm-up and motivation and orientation and so on, because a lot of times students get into Riemann sums and they don't understand why in the world we would go through this notational mess. And actually, historically, it appears that Riemann sums has not been covered in 126b, but I thought it was really important because I think that if you just go through and learn integration methods, I mean, first off, so it's good to learn them just so that you get some more practice with mathematical manipulations, so that you can check your answers or something like this. The reality is at this stage you can stick it into an integral calculator if you actually need to do an integral. So I think what's more important is really understanding what's going on with integration. And that's going to allow you to set up your own integrals if you want to, that you can then stick into a calculator, or at least have a good intuitive feel and sense if you see integrals as to what's actually going on with them. And I think that's much more valuable than becoming as fun as it can be. I actually like integration because it's kind of fun. You can look at it and be, oh, what do I do here and do here? And you can see how fast you can do it. Or you can feel really clever and so on. It's kind of fun. It's like a game. But I feel like that's much less important than understanding the ideas of what's going on so that mathematics has real meaning to you instead of just being numbers and symbols. So this is kind of the other part I want to talk about. And then I'm also going to supplement all of this with a video that I made with an undergraduate student I was working with, is a USRA student, Demera, and a master's student I was working with actually on topological data analysis, Troy. And we made a video on Riemann sums to give you yet another way to kind of look at them, because I think they're actually the most important part of integration. So here we go. So I'm going to start with, actually I'm going to start with a picture. So I'll do my axes in green. I know I'm switching my colors a little bit. It's good to have consistent colors, but we're not doing that yet. Okay, so we have some kind of x and y, and then we have some kind of function. So then I have an interval that I'm interested in, which is going to be a and b. And then I have some kind of function. Y equals f of x, so I've graphed that function. And then what I'm really interested in is finding this area underneath here. So right now I'm assuming that all of the output values for my function are positive. But for negative ones, you just end up taking minus area for when it goes underneath. So this area is going to be S. Okay. So what we're interested in doing is we want to find the area of S. Of precisely this region S. Okay? So we're looking at an interval AB. We're looking at the area underneath the graph of a function. And for us, you know, often that's actually our rate of change. We're trying to transform back. Okay? And this is the same process. Okay, so this is the same process as when I go from a rate to a quantity. Okay. So here we're starting out with, so I have a function f. It's blue over there, so maybe I'll still make it blue. But then we're going to go over to the area under f. Okay, which is the red thing. At the same time, I can go from f, so these are all the same process, which is to go to the antiderivative or integral of f. And then this is the same process as going from this kind of rate f over to the quantity, which is like this antiderivative. So every time I'm writing each of these things, these are all the same process. So it's good to keep that in our mind. And then the last thing I really want to emphasize here, and I'm going to emphasize, so emphasize to me means I'm going to write it in big capital letters, which is that Riemann sums, now they are used in formal mathematical proofs, but they are not just crazy theoretical nonsense. In fact, I'll write just, because we do also use them in abstract math proofs. Okay, I hope my exclamation points made it onto the board, at least one of them. Okay, and here are some reasons. So approximation is super important. Often, it's, we're going to learn about integrals you can compute, but you usually can't actually use them. So it's just like most differential equations can't actually be solved. Most integrals can't actually be computed using normal methods. And so one actually has to kind of learn to approximate them to as close as you actually want. Or this is also how, when you're getting these output numbers, like a computer, if there isn't really a set way to compute an integral, they'll actually use approximation techniques to give you an output value. Okay, and they allow us to see, as you kind of have seen in the previous circumstance, how rates change into quantities. Okay, and they help to see the appropriate integral to compute. A lot of times things aren't just given to you, but if you can kind of break them apart, then you can actually see how to do this. Okay. So this kind of gives you an idea of what we're doing with Riemann sums. We're going to be trying to approximate this area so that when I start getting into all this notational, it's going to feel maybe even a little overwhelming, that you have the picture in mind of what we're aiming at and kind of why we're doing it. So I hope that makes some sense, and I'll see you in the next lecture.